Welcome to Lesson 12 of Module 3, Exponential Graphs. Some key information about exponential graphs are the coefficient A and the base B, right? So if you look at this equation here, this is the general form of an exponential function, y equals AB to the x. A is your starting value, so your y-intercept, and B is your growth or decay factor. So that's the number that you're going to multiply each y value by to get to the next one. To plot key points, you'll start with x equals 0. So if x equals 0, then y would be equal to A. And then substitute x values in to find additional points. That's if you want to graph it by hand, but you have the graphing calculator, so I would just put it into the graphing calculator and get your points that way. Draw the asymptote. For most cases, the asymptote is y equals 0. So an asymptote is this imaginary horizontal line that the exponential graph hovers over but never crosses. And for a lot of these functions, it's y equals 0, which is the x-axis. Then you want to sketch the curve. So exponential functions can get kind of messy when you're graphing because of the way that they behave. So you just want to smoothly connect the points showing exponential growth or exponential decay. They're not the easiest graphs to graph by hand and make them look pretty. So let's take a look at this function here. Y equals 1 times 2 to the power of x. And I have the graph here. So let's take a look at the pieces of the equation and how they correspond to the pieces of the graph. So 1 is your y-intercept, and that's at 0, 1. 2 is your growth factor. That means in order to get from 0, 1 to the next point, we're going to multiply 1 by 2. And our next point would be 1, 2. To get the next point, we're going to multiply 2 by 2. And we'll get the point of 2, 4. Then we'll multiply 4 by 2. And we'll get 3, 8. And so on. Please pause this video and work on the Lesson 12 Level 1 problems in the workbook. So now let's take a look at more characteristics of exponential growth and exponential decay graphs. When b is greater than 1, the graph shows exponential growth. When b is between 0 and 1, the graph shows exponential decay. So you should remember this from the previous lesson. When we looked at those exponential growth and exponential decay word problems, it's the same concept here. So notice how the b value is positive 2. So our graph is going up, it's growing, it's showing exponential growth. And here the b value is 1/2. 1/2 is between 0 and 1. So this graph is showing exponential decay. And your initial value, that's your y-intercept. Please pause this video and work on the Lesson 12 Level 2 problems in the workbook. In Level 3, we'll talk about transformations of exponential graphs. So first, let's talk about vertical shifts. When your equation is in this form, a times b to the x plus k is going to represent a vertical shift. When k is greater than 0, or when it's positive, your graph shifts up. So we have here in this graph, the red graph is y equals 2 to the x. That's the original function. And then y equals 2 to the x plus 2. Because of this plus 2, that whole red graph just shifted up 2 units. And now the asymptote becomes y equals k. So in this case, y equals 2. Notice how the graph is hovering over y equals 2, but it will never cross it. And when k is negative, the graph shifts down. So in this case, we have our original graph, y equals 2 to the x, and then the blue graph represents a vertical shift down of 2 because we have y equals to the x minus 2, right? And now your asymptote is y equals negative 2. The graph is hovering over y equals negative 2. We can also have horizontal shifts. So if your equation is in the form of y equals a times b to the x minus h is going to represent a horizontal shift. So when h is negative, the graph shifts right. And when h is positive, the graph shifts left. So again, opposite of what you would think. Notice how it's always the x value where we have to think of using the opposite side. Right? So in the first graph, since the exponent becomes x minus 3, that means the graph is shifting to the right 3 units. And in the second graph, since the exponent is x plus 3, the red graph shifted to the left 3 units. We can also have reflections either over the x-axis or the y-axis. So when a is negative and your equation is in the form of y equals negative a times b to the x, that's a reflection over the x-axis. A reflection is like a mirror image. So imagine flipping the graph over the x-axis, so vertically, because it's over the x-axis. And when the exponent is negative and you have y equals a times b to the negative x, that's a reflection over the y-axis. So it's flipping horizontally over the y-axis. Please pause this video and work on the Lesson 12 Level 3 problems in the workbook. Once you're finished with the problems in the workbook, please stop this video and move on to the next one for Lesson 13.